Next. Let's solve this question. In an isosceles trapezium ABCD, AB is parallel to CD. Also, AB is longer than CD. So AB is a longer among these longer between these two parallel lines. Angle B is given as 60 degree. It's a isosceles trapezium. So angle A would also be equal to 60 degree, right? And AD is given as 10. And then length of CD is given as 18 centimeter. We have to find the area of this trapezium ABCD, right? So let's just first draw the diagram. I know it's a isosceles trapezium and angles are 60 degree. So it's a isosceles trapezium. So this is the trapezium. Let's just call this point as A. AD is given as 10 and CD is given as 18 centimeter. AB is longer than CD, so this must be the side AB. Then this C and this is D, right? Angle B is given as 60 degree. Length of CD is given as 18 centimeters and length of AD is given as 10, right? And because it's an isosceles trapezium, these two non-parallel side must be equal. So the length of this side CD or BC would be equal to 10 only, right? Now we have to find the area of this trapezium. I know to find the area of trapezium, we need to know the lengths of these two parallel lines, also the height between these two parallel lines. So let's just drop the perpendicular from this point. We will call it the height h. Now observe carefully. It's a 90, 60 and 30 triangle, right? It would be a 90 degree, 60 and 30 degree triangle. So for a 90, 60 and 30 triangle, we know the ratio of the sides. For a 90, 60 and 30 triangle, we know the ratio of the sides. So the ratio of the sides of this triangle are as, say, opposite to 60 it is √3 and opposite to 30 degree it is 1, right? So side opposite to 90 degree is given as 10 centimeter. So this 2 unit is equivalent to 10 centimeter, right? So this height becomes, I can find the value of this side or this height. This height becomes side opposite to 60 degree, which is √3 unit, or it become 5 √3 centimeter. So I get the value of height as 5 √3 centimeter, right? And the length of this segment, this line segment, I'm calling this point as E, right? So the length of BE becomes the side opposite to 30 degree, and the side opposite to 30 degree would be 5 centimeter, right? Because the value of 1 unit is 5 centimeters. So it is 5 centimeter. Similarly, drop a perpendicular from this point. So, and these two triangles are congruent because they are same. So you will get the value of AF as 5 centimeter and you will get the value of this height as 5 √3, right? So just by dropping the perpendicular, these two lengths are known. First, height is known. Also, now I can find the value of this parallel side AB, right? It is 5 centimeter. It is 5 centimeter because these two triangles are 90 degree, and these two sides are parallel. These angles are 90 degree. I can say this side CD would be equal to side EF. So it is 18 centimeters. Okay. So you will get the value of length of this side AB would be 18 plus 10, 28 centimeter, right? So area of trapezium is given by half into sum of parallel sides into height, right? Just place the values. Sum of parallel side would be 28 plus 18, that is 46. So it becomes 1 by 2 into 46 into height, and height is 5 root 3. So it is multiplied by 5 root 3. It becomes 23 into 5, which is 115 root 3. Correct answer would be option A. Right?